Good morning, students. Welcome to the second lecture, Laws of Gaseous State. The temperature, pressure, amount and volume of a gas are independent, and many scientists have developed laws to describe the relationship among them. First is the Boyle's law, named after Robert Boyle, who first stated the law in 1662, which states that if temperature is held constant, volume and pressure have an inverse relationship. That is, as volume increases, pressure decreases, or pressure into volume will be a constant. That is, P1 into V1 equal to P2 into V2. A good example of this is when you fill a tire with air. As more air goes in, the gas molecules get close together, reducing their volume. As long as the temperature remains constant, the pressure increases and finally the tire bursts. The next is the Charles law. It is proposed by Jack Charles in 1802. The law states that when the pressure of a gas is held constant, the temperature and volume will be in direct proportion. That is, volume is proportional to temperature at constant pressure, or it can write V1 by T1 equal to V2 by T2. Heating a gas increases the kinetic energy of the particles, causing the gas to expand. In order to keep the pressure constant, volume of the container must be increased when the gas is heated. Thus, Charles' law explains why it is an important safety rule that you should never heat a closed container. Increasing temperature without increasing volume makes the pressure to be increased and it leads to explosion. The next law is the Avogadro's law. In 1811, Italian scientist Amedeo Avogadro proposed the idea that equal volumes of gas at the same temperature and pressure will have an equal number of particles regardless of chemical nature and physical properties. That is, volume is directly proportional to number of moles at constant temperature, or V1 by N1 equal to V2 by N2. For example, if you are forcing more gas molecules into a container, the volume must increase at if temperature and pressure constant. That is, the volume must increase to keep the temperature and pressure constant. Next law is the Gay-Lussac's law, which also relates pressure and temperature with volume. States that at constant volume, pressure and temperature are directly related. That is, as temperature increases, pressure increases if we do not change the volume, or P1 by T1 equal to P2 by T2. The next law, Dalton's law, which is proposed by John Dalton in 1802. This law states that in a mixture of non-reacting gases, the total pressure exerted is equal to the sum of the partial pressures of individual gases. Here we are considering an example, that is, in this container, the first container, the oxygen gas exerts 2 units of pressure and the nitrogen gas in another container of same volume exerts 4 units of pressure. When the two gases are mixed, the total pressure would be 4 plus 2, 6, provided the volume of all the containers should be fixed. That is, the total pressure would be the partial pressures of each gases. These are the important laws of gaseous state. I hope you almost get the concept of different laws of gaseous state. Thank you very much, students.